A bee landed near you today, maybe in your garden, maybe near a window, maybe on the table where you were sitting outside. And for a moment it stopped, it stayed still. It seemed to be doing nothing at all, but it was not doing nothing. In that moment, that single bee was running one of the most sophisticated threat assessment processes in the natural world. It was reading your movement, your smell, your heat, your behavior, and within seconds, it reached a conclusion about you. A conclusion that would not stay with that bee alone. Because once a bee decides something about you, the hive finds out. Tonight, we are going inside the moment that most people never think about. The exact second a bee makes a decision about whether you are safe or dangerous. How that decision travels through an entire colony faster than you can walk across a room. What gets communicated about you in the darkness of the hive. And why the bees in your garden may already have a collective opinion about you that has been building for longer than you realize. What you are about to learn changes what it means to be near a bee. And once you understand it, every encounter will feel completely different. Here is something that almost nobody thinks about. Every time you have ever been near a bee, a decision was being made, not slowly, not lazily, with extraordinary speed and precision. The bee's nervous system was processing dozens of simultaneous inputs about you in real time. And somewhere in that processing, a classification was happening. One that has enormous consequences for everything that follows. Safe or not safe. Those two categories are among the most important distinctions a bee makes. More important than finding food. More important than almost anything else. Because in a colony where thousands of individuals share a single enclosed space, where a single mistake can trigger a cascade of defensive behavior that puts the entire colony at risk, the ability to accurately assess threat is not optional. It is survival, and bees are extraordinarily good at it. But here is what makes this strange. The decision the bee makes about you is not just about you in that moment. It is about you as a pattern, as a recurring presence in the environment, as a set of signals that the colony will remember, reference, and act on long after that individual bee is gone. To understand how this works, you need to understand something about how bees experience the world, something that researchers spent decades trying to fully map, and what they found was far more complex than anyone expected. A bee does not experience you the way you experience another person. When you see someone approaching, your brain processes their face, their body language, their expression, their history with you, all in a fraction of a second. You reach a conclusion about their intentions almost instantly, drawing on years of accumulated social experience. A bee does not have years of social experience with humans, but it has something else. Something that evolution spent 50 million years perfecting. A set of sensory systems so precise, so finely tuned, that they can detect information about you that you are completely unaware of producing. The first thing a bee reads is movement. Movement is the most fundamental signal in a bee's world. Everything important either moves or causes movement. Flowers move in wind. Predators move toward the hive. Danger moves suddenly. Safety tends to stay still or move slowly and predictably. Your movements are an extraordinarily complex signal for a bee to interpret. The speed of your walking, the rhythm of your breathing, the sudden gesture of your hand, the way your head turns, whether you are moving toward the hive or away from it, whether your movements are predictable or erratic. A bee watching you from a flower processes all of this simultaneously, and it is not neutral processing. Every data point feeds into a continuous calculation. Is this object a threat? Is it getting closer? Is its behavior consistent with danger? Fast, sudden movement is one of the strongest threat signals a bee can receive. This is not arbitrary. The natural predators of bees, bears, large mammals, birds of prey, all tend to move quickly and unpredictably when they attack. Evolution has wired bees to treat sudden movement as a warning sign, which is why people who panic near bees and start waving their arms are doing exactly the worst thing possible. They are sending a threat signal with their body that the bee cannot ignore, but movement is only the first layer. The second thing a bee reads about you is something you cannot control at all. Your smell. Humans are accustomed to thinking of smell as something relatively simple. A perfume, a food, a flower. But the chemical information you release into the air around you is staggeringly complex. Your body produces hundreds of volatile compounds continuously. The specific combination is as unique to you as your fingerprints. And while human noses cannot detect most of these compounds at all, a bee's antennae can. Bees evolved their extraordinary sense of smell primarily to navigate the chemical world of flowers. But the sensitivity that evolution gave them for detecting nectar sources also means they are receiving detailed chemical information about every large organism in their environment, including you. What does a bee smell when it is near you? Research suggests it detects your basic metabolic signature, the compounds your skin produces, the particular combination of chemicals in your breath. Whether you have been exercising recently, which changes your chemical output significantly, whether you are experiencing fear or stress, which produces measurable changes in human chemical emissions that bees can detect. This is where something uncomfortable enters the picture. The folk belief that bees can smell fear is not entirely wrong. It is not that bees detect an emotion. They cannot. What they detect is the physical response to fear. When humans experience fear or stress, adrenaline enters the bloodstream. Heart rate increases. Sweating increases. The specific chemical composition of sweat changes. These are real, measurable, physical changes that alter the chemical signature a person produces. And bees notice, not because they understand what fear is, not because they have any concept of human emotion, but because the chemical changes that accompany fear in humans produce signals that bees have evolved to pay attention to. Signals that, in the natural world, often correlate with the presence of threat. A person who is calm near bees smells different from a person who is frightened. And bees treat those two people differently. This is not mystical. It is chemistry, but the effect is real. Now here is where the decision happens. The bee has been reading you, your movement, your smell, your heat, your behavior in this specific moment, in this specific environment. And somewhere in its nervous system, a threshold is being approached. Below the threshold, the bee continues what it was doing. You are background. You are part of the environment. Noted, processed, filed, not acted upon. Above the threshold, everything changes. When a bee determines that something in its environment represents a threat above a certain level, the response is not gradual. It is immediate, chemical, and it spreads. The bee releases alarm pheromone. Alarm pheromone is one of the most powerful chemical signals in the bee world. It is a specific blend of volatile compounds that carries one message and one message only. Danger is here. Respond now. The release happens in an instant, invisible to human senses, completely undetectable without specialized equipment. But within seconds, every bee within range of that chemical signal receives a message, and they respond, not slowly, not gradually, with the speed that 50 million years of survival pressure produces. Guard bees shift their posture. Their alertness increases measurably. Their response threshold drops, meaning it now takes less stimulation to trigger a defensive response. Forager bees change their flight patterns. The hive entrance sees increased activity. The entire colony, which was operating as a calm, productive system 1 minute ago, has shifted into a heightened state of vigilance. All because of you. All because of a decision one bee made in a fraction of a second based on your movement, your smell, and your behavior. But this is where the story becomes truly strange, because the alarm pheromone does something that most people never think about. It does not just warn the bees that are present, it leaves a record. The chemical compounds in alarm pheromone do not disappear instantly. They linger in the environment, on surfaces, in the air, in the wax of the comb. For minutes, sometimes longer, the chemical signal of danger remains detectable, which means that bees arriving at a location after the threat has already passed can still detect that something alarming happened there. The environment itself carries the memory of the event, and bees respond to that residual signal. Now think about what this means in a practical sense. If you have ever had a bad encounter with bees near a particular location, near a hive, near a flowering plant, near a part of your garden where a colony forages, that encounter left a chemical trace. Subsequent bees visiting that location detected that trace, and they arrived already primed, already alert, already closer to the threshold that triggers defensive behavior. You did not return to a neutral situation. You returned to a location that had been chemically marked with a record of a previous threat event. And the bees there, none of whom were present for the original encounter, treated you accordingly. This explains something that many people have experienced and never been able to explain. Why certain locations seem to consistently attract more bee attention. Why some places always feel more tense with bees than others. Why an area that seemed fine for months can suddenly feel different after a single alarming incident. The chemistry persists. The record remains. The bees respond to what the environment tells them happened. But the communication does not stop with pheromone, because the bee that made the decision about you goes home. And home is where the real information transfer happens. Inside the hive, in the darkness that humans never see, the returning bee does what returning bees do. It moves through the colony. It interacts. It communicates. And the information it carries about what it encountered, about the threat assessment it made, about the specific location and nature of what it detected, that information spreads, not with words, not with images, through the same extraordinary chemical and vibrational language that allows a colony to coordinate thousands of individuals without any central control, through a system so efficient that researchers are still uncovering its full complexity. And here is what that means for you. The bee that hovered near your face this morning, the one you waved away without thinking, it went home. It communicated. It contributed its small piece of information to the colony's collective picture of the world around the hive. Your garden is part of that picture. Your movements are part of that picture. Your smell, your behavior, the specific character of your presence and space around the hive, all of it feeding continuously into a collective intelligence that never stops updating, never stops learning, never stops adjusting its understanding of the world. The bees in your garden are not experiencing you as a stranger. Not anymore. If they have been foraging in your space for any length of time, you are already known, already classified, already part of the information landscape that shapes how they behave, which raises a question that researchers have only recently begun to investigate seriously. Can you change that classification? Can a person who has had consistently alarming encounters with a colony, who has been classified as something close to a threat, change that assessment over time? The answer, based on what scientists now understand about bee learning and colony memory, appears to be yes, but not quickly and not easily. Because changing the classification in a colony is not like changing one bee's mind. It is like changing the collective opinion of thousands of individuals who are continuously reinforcing each other's assessments. Consistent calm behavior over extended time periods can shift the chemical and behavioral information the colony receives. Slow movement, predictable presence, no sudden actions near foraging areas. Over weeks, the signal the colony receives about a particular human can shift. But the opposite is also true. A single alarming incident can undo a long period of peaceful coexistence. A single sudden movement near a hive entrance. A single application of the wrong scent in the wrong place at the wrong time. A single moment of panic that releases the chemical signals of fear into the air near a foraging area. The colony updates, the classification shifts, and the bees respond accordingly. You've been moving through a world of continuous bee assessment your entire life. Every time you've been in a garden, near a flowering tree, anywhere that foraging bees work, you've been read. Your movement, your smell, your behavior, all of it is fed into countless small decisions that you never notice happening. Most of those decisions concluded that you were not a threat. Most of them went nowhere. Most of them left no lasting trace. But some of them did. Somewhere in your past, in a garden or a park or a backyard on a summer afternoon, a bee decided something about you and told the others. The next time a bee hovers near you longer than you expect, or seems more interested in you than the flowers nearby, or returns to you again and again despite you moving away, consider the possibility that you're not encountering a random insect responding to random stimuli. Consider the possibility that it already knows something about you, and that the hive knows it too. What that knowledge is and what the colony does with it is something that depends on everything that came before this moment. Every encounter, every movement, every chemical signal your presence produced near a hive that has been quietly updating its understanding of the world around it, including the world that includes you. Subscribe to the Bee Mind. And click here because the next video reveals something that happens in a hive after dark that changes everything you think you know about what bees are capable of.